To every action, there is an equal and opposite reaction. This is the statement of Newton's third law of motion. However, this is the most popular and yet the least understood of all of Newton's laws. To understand this law, let us observe what happens to this green ball as it hits the purple ball. When both the balls have an equal mass, the green ball stops upon hitting the purple ball. When the green ball has a greater mass, it slows down upon hitting the purple ball. And when the green ball has a lesser mass, its direction of motion changes upon hitting the purple ball. In all these examples, we saw that the velocity of the green ball changes when it hits the purple ball. Now, this is possible only if the purple ball also exerts a force on the green ball. Hence, whenever the green ball exerts a force Fgp on the purple ball also exerts a force Fpg upon the green ball. Here, Fgp is called the action force and Fpg is called the reaction force. So then in the equation form, Newton's third law could be written as Fgp is equal to minus Fpg. In this example, we can clearly see that Fgp and Fpg are in opposite directions. However, it would be difficult to explain that these forces are equal as well. So let us now see an example to understand that action and reaction are also equal. Consider this situation. Every time the right hand exerts a pull, we also see an equal reading in the force meter held by the left hand. This happens even if the left hand is not pulling at all. This means that when the right hand exerts a pull force, the left hand exerts an equal and opposite pull force. Now that we know that forces always exist in pairs and that they are equal and opposite, let us look at some action-reaction pairs. Consider a book lying upon a table. The weight of the book pushes the table downwards. This is the action force. The table exerts an equal upward normal force on the book. This is the reaction force. While walking, a man pushes the ground backwards. This is the action force. The ground pushes the man forward with an equal force. This is the reaction force. While flying, a bird pushes the air downwards and backwards. This is the action force. The air pushes the bird upwards and forward with an equal force. This is the reaction force. I hope you have now understood Newton's third law of motion. Nonetheless, let us clear certain misconceptions. In this example, the boy hitting the football is the action. However, the reaction is the football hitting the boy back, not the flying of the football. Here we have two forces of 5 Newton acting on a body from opposite directions. These two forces are not an action and reaction pair, despite being equal and opposite. This is because action and reaction act upon different bodies, not the same body. Then we get back to our green and purple balls example. The purple ball exerts a force on the green ball at the same instant the green ball hits the purple ball. Action and reaction happen simultaneously, not one after another. Now, let us use this law to explain certain common observations. Consider this person who is on roller skates. To move forward, the person pushes the ground backwards. In spite of this, the ground does not move. So let us understand why the person moves, but the ground does not move. Let us say the person exerts a force F1 on the ground. According to the third law of motion, the ground also exerts an equal and opposite force F2 on the person. So if M1, M2, A1 and A2 are the masses and accelerations of the person and the ground respectively, M1A1 would be equal to M2A2. That means M1 upon M2 would be equal to A2 upon A1. Now, the mass of the person could be 60 kg. This is in fact negligible compared with the mass of the Earth, which is 6 into 10 raised to 24 kg. Hence, the acceleration of the Earth is almost zero and the ground does not move. And now, the summary of this video. Newton's third law states that to every action there is an equal and opposite reaction. Forces always exist in pairs. Action and reaction are forces that act on opposite bodies. Action and reaction always act simultaneously. When one body exerts a force on another, the body with lesser mass has greater acceleration. So that's all in this video. In the next video, we will learn Newton's law of gravitation.